to properly introduce electricity to you, we're going to start with static electricity. And what I want you to know at the end of this lesson is how static electricity is formed. And I'll be interested to see what you learned from the Education Perfect work that was set for you along the way as well. Okay? So that's the goal today. Explain how static electricity is formed. And you can see I've got some of our classic equipment set up here to teach static electricity. And I'm going to need some volunteers to help me out with that. Oh. Okay. All right, let's start from this. Let's start from the beginning here. This is what I intended to do on Tuesday. All right. So the Achievement Center, you're sitting here, is demonstrate understanding of electricity and electromagnetism. So there's two major areas of this external that you're going to sit. Okay. So it's understanding of electricity and how it works, but also a concept which you possibly have never looked at before called electromagnetism. Okay. This is a big one, 6 credits, and this is going to take us to your exams at the end of the year. All right. So I'll put these notes on SharePoint as well. If you, I've already put them on SharePoint actually, and you guys can look at them from there and just recap and everything, anything that we've done today. All right. I'll just go real quick through a topic outline. This is what you're going to learn, okay, during the next 6 or 7 weeks that we have left. Okay. So the first thing we're going to start with is a concept of electrostatics. So what is what is static electricity basically? Okay, William, what do you know?
Oh, is it when two things like rub together?
Okay.
It's like makes a charge, positive charge.
Nice. Okay. All right. So we're gonna go through that. So the first concept today is static electricity, but we're gonna go through a step further here. We're gonna describe what field lines are, electric field lines. Okay, in different ways. You're going to be able to calculate electric field strength from that. Electric force, so a particle in an electric field, what happens to it, and the force that it experiences. And of course, we're going to look at electrostatic potential energy as well. Okay, which potential energy should be something that's familiar to you. Okay. Now from there, we're going to look at DC electricity. All right. And we're going to look at current. So we're going to look at the concept of current in series and parallel circuits. And I'm aware that some of you have never done electricity. You never learned electricity before, so it's going to be quite new to you. All right. We're going to look at voltage in series and in parallel. You're going to see a theme here. And resistance in series and in parallel. Okay, circuits. Calculating power, which should be familiar because we looked at power in level 1 mechanics and in level 2 mechanics. That was revised as well. And then going from there, electromagnetism. So we're going to look at magnets, obviously, and what magnets do and how magnets are formed and everything. Current and how current and magnetism are linked. So there's an actual link that goes on there. And a concept called the motor effect, which is quite handy for us because it helps us produce electricity, and solenoids. All right? Any questions? Let's start from the beginning. What are the 3 parts of an atom? William?
Electrons, neutrons, and protons.
Okay. All right, this is what you learned in level 1. Okay? Protons are larger and heavier than electrons. They have a positive charge, and they have a relative mass of 1. They're quite large compared to another part of the atom. Okay? We also learned about electrons, okay, and neutrons. Okay, electrons, relatively small, very small, okay, have a negative charge, and they are 2,000 times roughly. Okay, there's varying descriptions about the size of them, but they're about 2,000 times smaller than a proton, roughly. And then we have neutrons, which have no charge to them. They're similar size to a proton. And which 2 of these are located in the nucleus, William?
Protons and neutrons.
Nice. Okay. Now, there's one thing that's important about electrons, which you have to take into consideration when we're learning about electricity. Does anybody have any idea what it is? There's one very important property, one very important ability I should say, of electrons when we're talking about electricity. What do you think, William?
Is it because they have a negative charge?
That's true. Okay, that's one thing we could consider.
They flow.
Good. All right. They can move. All right. So the key thing here is they can move from one atom to another. We talked about this with ionization, for those of you who did the atomic and nuclear physics internal. So ionization, you guys talk about it in level 2 chemistry, ions. Okay. And the key thing here is that in certain materials, in certain elements, they become what is called delocalized. Okay? So delocalized is an ability to move. What is the best material in which electrons can become delocalized or move from one atom to another? What do you think? Henry? Conductors. What is the common material for that? Metals. Okay? There's a nonmetal. Does anybody know the nonmetal? You may have learned about this in chemistry, a nonmetal that actually can also conduct electricity. Does anybody know that? Water. Not water? No? Okay. I can see where your thinking is on that one.
Rubber?
No. That's what we call an insulator. Any other ideas? Graphite. Okay. So your pencil lead, okay, the material inside your pencil called graphite, it can also conduct electricity. It's made of carbon. It's got a delocalized electron in it. Okay. All right, so let's start here. We're going to look at two types of electricity. All right, so the first one is static electricity. Does anybody know what actually the definition of static electricity is? What is it, Corbin?
A lot of electricity in a pocket.
Okay, that's a good description. Anybody want to add to that? A lot of electricity in a pocket. I like to think in there, Corbin. Any other ideas, William?
Is it like when two negatively charged things rub against each other or something?
Okay, that's what's happening. That's what causes it. Okay, so that causes the movement of the electrons. Okay, but there's another key thing here. Okay, static. The word static is to stay in one place. Okay, so static electricity forms and gathers in one place. Okay? What's the opposite of that? What's the opposite of that? Any ideas? I mentioned it already in the topic outline that we did. Okay, the opposite of that is current electricity. So current electricity flows. We're experiencing current electricity right now in the wiring of this building. You, in a way, in your nerve cells have current electricity flowing through you. We're all electric, in a way. Okay? So current electricity is when charge moves from one place to another. All right? You could actually subcategorize current electricity into two subcategories. Any ideas there? Two subcategories.
Parallel and other one.
Okay, those are the types of circuits. Any other ideas, Nicole? Nice. Alternating and direct current, so AC and DC. All right, everybody's favorite Australian band. Okay, so current electricity, we're going to go into that later on, but we're going to focus mainly on DC, direct current. When you guys do level 3, you're going to do a whole topic on alternating current. All right. So William, you mentioned static electricity. How is static electricity formed again?
Two negative things rubbing together.
Good. All right. So we got this going on. So everybody's, so you possibly did this in junior science, looked at charging up an object with friction. You've all experienced this, I'm sure, rubbing your feet on the carpet, touching something metal. When you drive your car down the road, it builds up a static charge because the friction of the air molecules. And when you get out, how many of you have ever got out of a car and got zapped by the car? Okay? So that is caused because you're driving down the road and the friction of the air molecules is either removing or adding electrons to your car. Okay? Also with the road as well. Airplanes, something that people commonly don't know is that when you fly long distance in an airplane, the airplane gains so much electrical charge that you could actually get electrocuted if you touch the airplane coming off the airplane. They actually hook a metal cable to it, to ground it, to discharge the airplane before you get off of it. So it's quite intense. All right, so we're going to look at some, we're going to do some classic experiments here with our Van de Graaff generator showing static electricity. So I've set it up right in the middle here so everybody can see it nicely. I'm going to need somebody with nice, long, flowing hair. I think Tegan volunteered for this one. Not yet, Tegan. I'll have you do that in just a second. Okay? So, a Van de Graaff generator, just a quick description. Can you see all right, Hamish? I'm blocking you. Okay? All right, Van de Graaff generator. If you take that dome off, it's got a belt. And the belt has a comb on it that kind of rubs on it. And it's doing this charging by friction through that. And this big metal dome, quite thick metal, is a conductor, okay? And so what's happening is that as that's, and it's connected to that comb, so as it's rubbing and doing its thing, it's removing electrons from this dome. Now, right now, this is electrically neutral. What does that mean? All of the atoms, all the metal atoms, iron mainly in this, are electrically neutral. What does that mean, William?
No charge.
Has no charge? What else? What else does that mean? If it's electrically neutral. You guys should have learned this in level 1 chemistry, electrically neutral. Any ideas? William?
Balanced.
Good. What's balanced, though?
The electrons and protons.
Nice. Okay, so there's a balance of electrons and protons in there. Okay? Now if I turn it on, it becomes positively charged. So what is happening? Anybody explain? What is happening? Right now it's becoming positively charged. What's happening, Holly?
Removing the electrons, so it's got positive charges in it.
Good. It's removing electrons from it. So there's an imbalance of charge going on right now. All right? Electrons are being removed from this dome. Okay? Okay, and we could demonstrate the what's called a potential difference, which is also known as voltage, by doing this, discharging it. Okay, so right now I'm discharging. You guys can all see that. Probably helps if we have the lights off, actually. Okay, so right now it's becoming positively charged. Okay, hold on. All right, so we can see that. And if you let it build up enough, you can actually feel the electric field around it. Okay, if you let it go long enough. All right. Now there's a couple of things we can do here. First one, we got some polystyrene balls in this little thing here. Okay. Now this is connected to the dome now. What's going to happen to the polystyrene balls? So this is becoming positively charged, but what's going to happen to those now?
Vibrate.
Yeah. Okay. But why?
Because they're conductive.
Okay, actually it works better if I do that. Okay, any ideas? Can anybody explain? Okay, the dome is, remember, becoming positively charged. Electrons are being removed. What's happening to the polystyrene balls? Andy? Nice, okay. So the polystyrene balls are also gaining a positive charge. And they're repelling each other constantly. They want to stay away from each other. Okay? And so they're bouncing around and they're like crazy because of that charge. All right? Just charge that so I don't get electrocuted. All right? So that's one. Okay, this is always an entertaining one. Any predictions? What's going to happen, Nicole? They're going to fly off. Okay, let's see. Okay, why? Okay, they were all clearly made of metal, little pie tins. Okay, why have they flown off like that? Any explanation there? Corbin, what do you think?
They start becoming positively charged as well because the electrons get sucked out and positives repel each other.
Nice. Okay, so every single one of these has become positively charged. They're all conductors. They're all made of metal. Electrons are being drawn out of them. All right? And they're all being repelled away from each other, flying off. All right? And there's one more I can do here. This one actually works better with a balloon, but I tried it this morning and it worked. Okay? So I've got this aluminum can here. And if oh, sorry. Try that again. I'm just going to discharge that so I don't, okay. To do it that way. All right, so this is becoming positively charged now, this little globe here. All right, and hopefully this works. There we go. Okay, I'm not touching it, am I? Any explanations for that one? Can is made out of metal. Metal is a conductor. Why is it moving when I put this positively charged object near it? Any ideas? Any explanations? Holly, you want to have a go?
Because the negative charges in the can are being attracted to the positive charge.
Good. Nice. All right. So the electrons inside the can are actually being pulled to one side. Okay, it's becoming there's becoming a difference in charge in each side of it. So one side's negative, one side's positive. The negative side becomes attracted to the positive, and it goes. All right. Should we do the classic one here? All right. You feeling brave, Tegan? Let's go. You probably got some product in it too, don't you? Do you have product in your hair?
Yeah, a little bit.
I think it looks like it'll work. Pop your hands on there. Okay, make sure you're only touching that in the polystyrene box there. That's it, because I think, there you go. Go ahead. It's not going to, I've discharged it. Oh, look at that.
Already?
Yeah.
Yo.
Awesome. Wave it about. That actually worked really well. Oh,
Is it gangster?
oh yeah. Nice. It's worked really well, actually. All right, don't take your hands off yet. Actually, I'm going to keep it going. Can anybody explain again? How is static electricity formed? Why is William's hair doing that? Why is William's hair doing that? Anybody want to have a go explaining again? Thank you, Holly.
It's taking the electrons out of his hair, so the positive charges are repelling one another.
Good. All right, so electrons being drawn out of William. Okay, each individual hair is losing electrons. Okay, and becoming positively charged as a result. Each positively charged hair repels the other one, and so you got a nice static. Okay, don't take your hands off.
Oh.
There you go, discharged. All right. Okay. All right, could somebody, let's go back here. I need somebody to have a serious scientific discussion with me and explain how static electricity is formed. Okay, what do you know? What do you know? How is static electricity formed? Corbin?
Pockets of electrons.
Okay, all right. It has to do with electrons, good. Anybody else? How is static electricity formed? William?
They rub together.
Okay, so it's through friction. So the whole concept of rubbing your feet on the carpet, touching something metal, a car driving down the road becoming statically charged, an airplane flying through the air becoming electrically charged, our Van de Graaff generator, the belt rubbing on the comb, making that metal dome electrically charged. It has to do with electrons.